Are you looking to migrate to a different CPaaS provider, or do you simply want to make your real-time communication application CPaaS agnostic? Hey everyone, this is Hector from WebRTC.Ventures, and in today's video, we will explore an interesting approach that will allow you to separate your application logic from your CPaaS implementation. Let's get started. Over the life of your application, often at the beginning of the journey, using a CPaaS provider might be the right choice. However, as the application continues to grow, you may want to have more control over the communication features, or you might want to manage your ongoing costs. In any case, depending on how the application was built, making the required changes can become a very difficult task. So that's why in this video, we will show you how building an abstraction layer for the CPaaS implementation will allow you to have the benefits of a CPaaS provider without making your application too dependent on it. So let's use this very simple web application as an example. So in this application, I can join a call by clicking the join button. And you can see that I have my local media streams already rendered in the page. So let me duplicate the tab, and now I will click on join to simulate a second user joining the call. Okay, so we have a video session established, and if we go to the WebRTC internals page to see the details of the connections, we can see that we are using Twilio platform. We're using the Twilio size servers, and the call is being established using Twilio CPaaS provider. So the interesting part of this application is that in this case, I will do it through code, although you can implement a different mechanism if you want. So I will go to the code and I will change from Twilio to something like the Amazon Chime SDK. So I will save the changes and I will refresh the tabs. Now, if I click the join button, you can already see that the interface has changed, and this is an indication that we are using a different service. Now, it doesn't have to be like that. This can be completely transparent for the end users. I just did this in order to know when we change from one platform to the other. So I will go to a second tab, click on join, and now we have the same video call established, but now using the Amazon Chime service, the Amazon Chime SDK service. So if we go to the WebRTC internals and check the details of the connections, you can see that now we have a different set of iServers, which also tell us that it's using a different CPaaS provider now, same as for the other connection. And this doesn't have to stop here. You can support as many CPaaS providers as you like. So now we're gonna move from the Chime SDK, from the Amazon Chime SDK to something like the Vonage Video API. So I'm gonna put here OpenTalk, save. So now refresh the pages, the tabs, and again, I'm gonna click join. We have a new UI change to reflect that we are using a different platform, a different provider. And I'm gonna do the same in the other tab. And again, we have a video session established. And if we go to the WebRTC internals, we can see that we are using a different set of iServers as an indication that indeed we are using a different CPaaS provider. Now, how does this work? Let's take a look at the code. As I mentioned, this is a very simple web application written in Vue.js using the Nuxt framework, the Nuxt.js. So we have a button and also a couple of div elements to show the media streams. We also have a constant where we set the CPaaS provider that we want to use. And then we make a request to a backend by passing a room name to be created, and also the desired CPaaS. This backend will in turn authenticate us with the corresponding platforms and returning an appropriate set of credentials. Now, all the magic happens within this call service layer, where we initialize a video call client using the selected CPaaS and also the credentials that we got from the servers. When we have initialized such a client, we can call a set of predefined functions like init sessions. We can register a callback for when we got on stream, and also subscribe to remote streams. We can set up our own media streams using init publisher, and we can finally connect to the sessions. All these methods are completely customizable depending on the logic of your own application. So let's take a look at the call service plugin. Since we're using Nuxt.js, we can define custom plugins. And the plugin is nothing else than a wrapper around multiple call clients. We will have a call client for each of the supported CPaaS providers. So when we initialize a client, we receive the type, which in this case will be one for each CPaaS provider, and the set of credentials. Then we instantiate the appropriate objects for each of the clients. And we also have the definitions of the methods or actions that we want to support. Depending on the logic of your application, you might need to add more of these. And let's also take a look at the actual clients, which is where the CPaaS related logic will live. So you can see that we are initializing sessions using the OpenTalk library, initializing publisher, and the same applies for the other clients. So for instance, we have the Twilio's one here, and we also have the Amazon Chime SDK one. So if you want to learn how to build these kind of abstraction layers, in the descriptions, you will find a link to a blog post where we explain how to do this step by step. And you can also find the code of this application and also for the backend in the description of this video. As you can see, abstracting the CPaaS provider implementation allows you to have a consistent media flow that's completely agnostic of the provider that you're using. This in turn enables you to easily move from one to another or even migrate to hosting your own infrastructure without having to make big changes in your application logic. If you're looking into building your application using a CPaaS provider, or do you want to migrate to a different one, at WebRTC.Ventures we are experts at building high-quality real-time communication applications using WebRTC. Contact us to know more about our services at WebRTC.Ventures/contact. Be sure to follow us on Twitter and LinkedIn as WebRTC.Ventures and WebRTC.Ventures respectively. And don't forget to subscribe to this channel for more WebRTC tips. Let's make it live!